Hello everyone, myself Paula Mokwana, Assistant Professor of EC Department at LJ Institute of Engineering and Technology. Welcome to the session of Digital System Design. This is a simple way of looking at the Scalar shifting. See, over here input data in. Input is there, 1. Okay? At the edge of the clock pulse, it will be shifted like this. At the edge of the clock pulse, it will be shifted like this. Over here. Again, at the edge of the clock pulse, it will be shifted over here. This is shift right operation. Okay? As we need to shift the data when it is a 1011. First clock pulse 1 is inserted, second clock pulse this 1 is inserted, third clock pulse 0 is inserted, and the fourth clock pulse it is 101. Okay, and for the output again clock pulse is there, so 1 will be out. Right? Now it's logical diagram. Over here we are going to shift the right, doing shift right operation. We are going to transfer the 4-bit sequence, it is a 1010, which is going to be loaded into the 4-bit in, serial out shift register. 4 D flip-flops are there. Serial input, over here we are going to get the leftmost flip-flop and the output is taken from the rightmost flip-flop. Okay? And each individual flip-flop will get the clock pulse. At the edge of the clock pulse, the data in is going to be inserted with the help of the lower flip-flop, leftmost flip-flop. Okay? And the 4 clock pulse is required to lower the resistor. Right? So this diagram shows the 4-bit sequence 1010 is going to be transmitted and will be unloaded after from the 4-bit serial in serial out shift register. So each bit will move one position to the right at each and every time. Okay? So 4 clock pulse requires to unload the resistor. Okay? 4 clock pulse for loading the resistor and another 4 clock pulse to unload the resistor. So they are often used for the communication, data communication, like RCD loop, for modern transmission reception, Ethernet links, and so on. Okay, this is the example of n bit serial in, serial out. Serial in is there, serial out is there. Alright. Now serial to parallel conversion. Over here, serial input is there and parallel output is there. So we often need to convert serial data to parallel data. So over here, serial SIPO, serial to parallel, serial input, parallel output is used. So after receiving a series transmission, we are able to transmit the data parallelly. Okay, so this diagram illustrates serial input and the parallel output with the help of this 4 clock pulse and the 4 flip-flop. Okay, serial input is applied to the leftmost flip-flop and the outputs are taken parallelly. Okay, Q0, Q1, Q2 and Q3. So we are going to use a serial in parallel out shift register with a D flip-flop. Okay, so if you need to construct the n bit serial to parallel conversion, you need to use n D flip-flop to load that particular value. Okay, so these 2 shift registers are used to convert serial to parallel data. The upper shift register will grab the data once it was shifted. Okay, if shifting is done, data will be grabbed. Now the parallel to serial conversion. So we are going to use parallel in, serial out shift register. So data is going to be applied in the parallel form to the parallel input base. So parallel inputs are going to be given to this shift register and the serial outputs are taken one by one. So 1 clock pulse is required to load the resistor. Okay, and 4 clock pulses are required to unload the resistor. Right? So the parallel to serial conversion requires logical circuit will be like this. It requires a clock pulse, it requires whether we need to load the resistor or shift the resistor, the serial in, it is by default 0, and for the parallel inputs, it requires based on the how many conversion is required. Based on that, we require the flip-flop, we require number of bits. Alright, so we need the n bit of shift register for the n bit conversion of parallel to serial. Right? Now for parallel to parallel conversion, that means parallel input, parallel output. So it is used to store or temporary data. So it is going to be presented in the parallel format to the parallel input pin. See, this is the parallel input is there, and over here parallel outputs are there. Alright. So one clock pulse is required to load the register, and one clock pulse is required to unload the register. Right? So what is universal shift register? So it can do a combination of parallel and the serial input-output operation. It requires additional input to specify whether in which direction I need to transmit, whether in the shift left, shift right, okay, or serially and the parallel. So we are going to use a MOS like the input getting. Okay, so it is called a universal shift register. So it will be look like this. Parallel in parallel out shift register will be like this. Alright. So universal shift register has these 4 inputs like serial in, shift enable, load enable, and the clock. And will we have parallel inputs like this, parallel outputs like this, and the serial output is like this. Okay. Based on whether we need to shift the data or load the data or we need to insert the data serially, and the most important, the age of the clock pulse, how my shift register will going to be triggered. So these 4 are the important for the operation of universal shift register. Okay, let's say the input is like, if my value of shift is 0 and load is 0, then my next state will be Q3, Q2, Q1, Q0. That means there is a no change. Okay. If load is become 1, shift is 0, then load operation will be performed. And for shift is 1 and whether value of load is 0 or 1, the shift right will be there. Alright, this is the way how universal shift register will work. Now, the MSI shift register, that is medium scale division, that how we are going to implement shift register in the form of medium scale in the form of IC. We are going to use a 74LS164, which is a 8-bit SIPO, serial in parallel out shift register. It is going to be operated on 35 MHz. It has a asynchronous master reset, serial data input, and the parallel data output. It is a fully synchronous. Alright. So it will be internally, it will look like this. It consists of 1, 2, 3, 4, 5, 6, 7, 8 different. It is an 8-bit shift register. This is a logical diagram of 74LS, that is SIPO, serial in, parallel out. Okay. Shift register. Internal logical diagram. Alright. Now it has a 8-bit serial in parallel out shift register. Its pin name is like AB for data inputs, CP for clock pulse, MR for master reset, and Q0 to Q1, Q7 are the outputs. Okay, its logical symbols are like this. VCC pin number 14, ground is a pin number 7. So it is a 14 pin IC. Serial input, parallel output. This is its pin diagram of the 14 pin IC. Right? So it is the age trigger 8-bit shift register with the serial data input and the parallel data output. So data is going to be inserted serially through whether one of the two inputs A or B. Right? So each low to high transition of the clock pulse gradient is going to be shifted. So the outputs at the Q0, so logical M22 data input set exists before the rising clock age. Okay. So MSI shift register which has operating mode reset and the shift. For the reset, the value of MR, A, B will be value of MR will be low, A, B has low character. Okay. So my output will become Q0 becomes low, Q1 condition will become low. Alright. For the shifting operation, the MR becomes the master switch will be high because it is active low signal. For value of A, it is low and B is low. The value of Q0 becomes low. And for the Q1 and Q2, Q1 to Q7, it becomes Q0 to Q6. Low means low voltage level, high means high voltage level, X means good there. Alright. This is the 8-bit 74LS166 8-bit shift register. It's logical it's a Venn diagram. This is the how it's going to be function based on the value of clear, shift and loading operation, based on the clock pulse, its serial values and parallel outputs. Alright. This is the how we can describe with the advocacy truth table. So the MSI shift register is a 74LS166. It's a 8-bit shift register which consists of this logical diagram. As it is an 8-bit shift register, it requires total 8 flip-flops. So based on that, this is the zoom view of this diagram of internal diagram of 74LS166. It consists of clear serial input, shift loading operation, and based on the value of A and B, we are going to shift the data whether it is serial or parallel. Okay. This is the example of timing diagram of the MSI shift register 74LS166. Based on the parallel inputs, what will be the output? If it is clear, my output will be 0. And based on the edge of the clock pulse, I will get the output. Alright, this is a timing diagram of MSI shift register. So over here, chapter number 3 is finished. So if you have any doubt, you can ask me right in the video. Till then, thank you for your attention.